Awesome! Finally got my replicator working. So basically it's a CTC printer from eBay, like 300 quid. Managed to do the control board, so I replaced it with the cheaper RAMPS version. I'm really pleased I did actually. Seems to be printing nicely. We've got a lot more options and control. The software seems to be better as well than the MakerBot software. A lot more options and kind of, I don't know. I guess there must be a lot of really cool people working on it and then giving away their work for free, which is open source magic. Obviously there's probably still plenty to play with. I'm going to make a better beam break finger for the optical sensors, and I'll print them off, and also a nice little case for the LCD. Would be cool, maybe something that just clips in the holes left by the old one. But I finally start to make 3D stuff. A funny feeling that the end caps that come off this are going to be stronger than the last one, because the last one was, I think it was under extruding. It was winding up with lines in the circular prints. It was shrinking in. So maybe I could print off some more and retest. I'm really pleased. Brilliant progress. I just made an acrylic sheet just to contain the bird's nest. I'll add a 80mm fan here, and it's got the original little small one there. So yeah, the ramps with the Mega underneath there, just the cheapo China drivers that came with, and then to power it, I wanted to try and avoid having an all separate ATX power supply for the steppers and the Arduino. Now the Arduino wasn't powerful enough to drive the LCD, so I added another little buck converter coming off the 24 volts going into the ramps board on the VCC pin on the ramps board, and then cut diode 1 so that it's just supplying 5 volts, and that keeps everyone happy. And then another one here for the stepper drivers. This is the one that might be the problem. Outputting 12 volts for the stepper drivers. I might crank that up a bit to like 17.5 volts, which is the most that these caps can take, to reduce the current draw, and hopefully that'll smooth stuff out with the steppers. And then the optical isolator stuff for the 24 volt switching. Heated bed, 2 heated plates, 2 fan on the hot end, and the stepper cooler fan as well. It's all 24 volts coming off these, just low side N channel FETs. Was it? Forget, but yeah. I tried switching the boost converter for the hot build plate here, along with the so that was on 40 volts. I was trying to switch the output of that, but when I was switching the output of that with the 24 volts next to it, the FETs were heating up. So I guess with the potential difference across its neighbour and the bed FETs, the body diode was conducting, because they're all common ground. And yeah, so I'm thinking something like that. Don't know enough about electronics, so I just had to go back to switching the input to the DC boost converter. Cranked it down a bit to about 37 volts, because the power supply was struggling with the 2 hot end heaters going at the same time. And obviously you need to make sure that you don't switch on the PID or pulse width modulation stuff for the heated build plate, because that'll probably upset the DC converter for the build plate. What else there is here? Still to do a nice front panel and tweak the steppers, try and get that crunch out of them. I'll turn the voltage up for the supply and see what happens. But yeah, I like lots. It's all good. And obviously they should be more reliable now with the thermistor inputs to the ramps board, and there's loads of stuff on the ramps and RepRap, so it's brilliant. Open source is the way to go.